Hello dear students, I hope you are enjoying this chapter. In this module, what we are going to discuss? We are going to discuss some MCQs based on Wheatstone bridge. But if you remember a Wheatstone bridge, that was a quadrilateral forming four resistances, and yes, if you remember the diagram, that was very important, a balancing condition. So I'll give you one very smart and a beautiful shortcut to understand this concept. So let's understand what is a Wheatstone bridge. Yes, it is a combination of four resistances connected as a quadrilateral. But dear students, do you see some more additional resistance, that is Rg? Please let me know what was Rg. Yes, Rg was the resistance of galvanometer, and that was the galvanometer that was used to find the deflection of the current. But we know that the structure is said to be Wheatstone bridge, and if this condition, that is R1 upon R2 should be equal to R3 upon R4 is satisfied, the bridge is balanced. And if the bridge is balanced, can I say galvanometer will show null deflection? Implies there is no current flowing through this branch, that is branch BD. And if current is not flowing, can I say the resistance is infinite? That means it is simply an open circuit. That means Rg is dummy and it can be removed. Please understand this concept, dear students. Now, if I remove this Rg, can I find the total resistance between point A to C? Yes, it's very simple. Can you see in the branch ABC, R1 and R2 are in series. So the total addition will be R1 plus R2. Similarly, in the branch ADC, R3 and R4 are in series. Again, it's an addition. So the answer is R3 plus R4. And across point A and point C, these two equivalent resistance are actually in parallel. That means in my school section, I know how do I solve two parallel, dear students? Yes, the equation is very simple. 1 upon R1 plus 1 upon R2. But R1 is RS1 and R2 is RS2. Hence, I get this equation as RP equal to RS2 into RS1 upon RS1 plus RS2. Confusing? Don't worry, dear students. We will try to simplify it more. But before going to simplification, let's try to see in what other ways in an examination the same bridge can be asked. So there are two different ways of representation of same Wheatstone bridge that is given to you in your videos. So please remember this diagram, dear students. If these diagrams are asked, it is nothing but a question for Wheatstone bridge. Now, moving ahead with our first numerical where we can simplify that difficult equation. The question is very simple. 5 identical resistance are having value are connected as shown, the equivalent resistance between P and R. That means, dear students, what he is asking me? He is asking me to find the equivalent resistance for a Wheatstone bridge. And can I say this resistance is actually forming a balanced Wheatstone bridge? Implies this R, which is nothing but a dummy resistance, can be ineffective and hence it can be eliminated. Yes, if this can be eliminated, dear students, we have already seen in our previous module, the resistance in the branch PQR has to be 2R because they are in series, and the resistance in branch PSR has to also be in series, which is nothing but 2R, and the total resistance, that is 2R and 2R, has to be in parallel, which is nothing but R. Now, dear students, please try to understand this equation. Do you see the final answer, that is R? So can I create a easy shortcut? Yes. What is the shortcut? If in a Wheatstone bridge all the resistances are equal and the bridge is balanced, then the total or the equivalent resistance is nothing but the value of individual resistance. So you need to remember this. This is very, very important shortcut. Now, based on this shortcut, please give me the answer for this very simple numerical. 5 resistance, each of 20 ohm. You are supposed to find the equivalent resistance. So can I say, dear students, if I am supposed to find the equivalent resistance, it has to be nothing but the value of individual resistance, and hence the correct answer has to be 20 ohms. Yes, dear student, don't you think this is very simple now? Okay, moving ahead with our last question for this module. The question is depicted as the equivalent resistance between X and Y is if all the resistance are of 4 ohms. Now, dear students, please don't get misconfused or don't get confused. It is nothing but the condition or one way of representation of your Wheatstone bridge. So that means if all the resistance are same, that is given in the question, can I say in a Wheatstone bridge, if all the resistances are same, the equivalent resistance has to be the value of individual resistance, provided the correct answer has to be 4 ohms. Thank you for this module.